Welcome. This is Odum Maths. Today I want us to look at a very interesting topic that normally comes during WASI or GCE mathematics. So we are going to look at plane geometry, and under it we are concentrating on circle theorems. Before then, let's look at parts of a circle or parts of circle. So the line drawn from the center, that is marked O, to this is the circumference of the circle. So we call that line radius. So let me indicate this by R, radius. If I draw another line from the center to touch the circumference, that is another radius. But in between them or this side is the sector. Sector. Okay, so we call this the minor sector, and then the rest the major sector. Then again, let me call this points A and this B. So from here to here is known as an arc of a circle. Then we call this the minor arc. Then from this point to B, also the major arc. Then again, if I draw a line from this point to join B, we call this line AB chord. So let me push it here, chord. Then the distance or the area between the chord and the circumference or the arc, we call it the segments. So we call the side the segments. The segments. So we can call the side the minor segments, then the rest major segments. Okay. Let me ask this question. We said the line drawn from the center to the circumference is radius. If I continue the line straight to this part, from this point to this point is the diameter. Is the diameter. Okay, now what's the name of this line? You can pause and answer, and then I continue, or play it later. Now, this is not a diameter, though it is per what we have on the board. It is dividing the circle into two equal parts, but no, it is not a diameter because it is not passing through the center of the circle, but rather it is just a line drawn from one end of the circumference to the other end. So this is never a diameter, but rather a chord. It becomes chord because the line is not passing through the center, or we've not indicated that this place is the center. So this can be the center. If this is the center, then still this is the chord because this circle is not drawn to scale. I hope it is clear. Okay, now let's look at the first theorem. Angles subtended at the center. Okay, so this is my center. I am marking it O. Now, if this chord or this arc, so let me join these points, name it A and then B. So I'm joining them together. That is from this point to this point. Okay. So this, if this chord or an arc subtend an angle at the center, then the same arc or chord subtend another angle at the circumference. The angle at the circumference and the angle at the center. Let's look at the relationship. If you want that of the center, you just multiply the one at the circumference by 2. So this is equal to 2 times of this one. Or if you want this one, you need to divide this by 2 to get this one. So that is that. So the theorem states that the angle subtended by a chord at the center is twice that of the angle subtended at the circumference by the same chord. Okay. Now let's look at theorem number 2. Okay. Now for theorem number 2, it is headed by angles in the same segment. That is the heading. Now what we are saying is from this point A to B, this line is the chord. So this is a segment. This area is called a segment. So this is a minor segment and this is a major segment. Now, if angles are subtended by the same chord at the same or in the same segments, these angles are equal. So like the same chord or the same arc, subtended angle at the angle at C, which is A, the angle at D, which is B, the angle at E, which is C. So we say that the angles A is equal to B, also equal to C. So these three angles are equal. We may get another one, maybe from this point to that point to here. That is also the same as these angles. So that is that for this theory. Now let's look at this example. We are to find the values of the angles marked X and Y. So we are finding the values of these two angles. So what do you think this will be? You can pause and play later. Okay, welcome back. Now, we said earlier that the value of these angles can be found by dividing this one into two equal parts, because these angles were subtended by the same chord or the same arc. That is arc AB or chord AB. So it means that to get X, just divide this one. So we can get X by dividing angle AOB. So AOB, angle AOB into two equal parts. And angle AOB is 60 degrees. So when you divide it into two, X becomes 30 degrees. Then again, to get Y, we said when a chord or an arc subtend the same angle or angles at the same segments or in the same segments, then these angles should be equal. So if X is 30, then it means Y is also 30 because X is equal to Y. So X equals Y, therefore Y is also 30 degrees. Okay, so we'll meet in the next lesson. Bye.